Hello, we are Team Dose presenting the Medical Dispenser Design Review 1.2. My name is Wesley Tiff.
I'm Clara Hall.
Drew Bell.
Ethan Yu.
Justin Mack.
And Quan Nguyen.
Moving on to our next slide, which will speak about our critical paths. We have our basic illustration above, which still has our medical and liquid dispensing systems, specifically the pill, an alarm-based system to notify our caretaker of intrusion, and a UI that will be customized for each customer. On the bottom block diagram, we have a more detailed view. We have our power source, which is connected to all the units. Externally, we still have our UI and our system integrated into the front door, where internally we have our sensors, our microcontroller, and the majority of our mechanical components still. Each group is separated so that there's no wiring issues or any room issues within the fridge unit. Moving on to our prototypes in the next slide.
Sorry, these are our risk reduction prototypes. The first is the rotating wheel that holds the vials for our liquid medicine. You can see that is the ones on the left here. The center one is a rotating wheel that will drop the dry medicines into a tray, and the picture on the right with the fridge is how they would be arranged in the actual fridge in the finished product. On the bottom right, you can see a simple circuit arranged to show how we tested the alarm system. So here are our RRPs in a little more detail. Our first RRP is medicine storage, where we would have to prove that our medicine dispensers were sufficiently small in order to be able to work inside of the fridge and properly dispense the medication. And through our observation, we have indeed established that it was able to store the systems. Our second RRP is user safety, which was basically being able to notify a potential caretaker about a breach into the system or any other malfunctions. And we managed to partially get this one, as we were able to notify the caretaker within the application, but we're not able to get a push notification through. Our third RRP is the liquid dispensing system, which was able to store and dispense at least one type and preferably 3 types of liquid medicines, and would demonstrate the ability to add different types of liquid medication. This one was not met, and we'll be going into detail about this later. The fourth one is the pill and capsule dispensing system, which stores and dispenses the dry medicine, and this one was met. And our final RRP, RRP5, is the reminder system, where we tested the ability to show a light and sound prompt on the device, but we were not able to meet the should requirement, which is an Android notification on a person's device.
So getting into specification 1 states that the fridge that we obtained shall provide space for the liquid medicine solely as its housing unit and should provide space for both the liquid and capsulated medicine within its enclosure. So the method that we used to test this specification involved obtaining either a tape measure or a ruler and just simply locating the ideal placement of the dispensing units by measuring the specifications of the refrigeration unit. Once we decided where each dispenser would best fit in the fridge, we measured those specifications of the refrigerator. This includes the depth, width, and height of the inside of the fridge, the height from the floor of the fridge to the single shelf that you can see built automatically into the fridge, the height from the shelf to the ceiling, along with all of the freezer components, such as the freezer width, height, depth, and the fridge door dimensions. So We had initially obtained one mini fridge that we started with. After measuring some of those measurements, we concluded that the freezer was going to be too large to provide for multiple dispensers, at least on the top shelf specifically. So we ended up obtaining a second fridge with measurements that are slightly different than the original fridge, but provide major benefits to our project because even a couple inches difference can allow us for more room to add more dispensers. So with those measurements, we then created dispensers on SolidWorks that could easily be placed inside the fridge by fitting our dimensions on SolidWorks with the dimensions of the fridge. So the test would be successful if the liquid dispensers fit inside and the refrigerator door closed and would surpass the specification if both the liquid and the pill medicines fit inside the refrigerator. A failed test would simply be if the medicine did not fit and the door did not close properly. As you can see in this photo to the right, both the pill and the liquid dispenser were able to fit inside the fridge, and so the specification was met. We actually also concluded that there was room to fit an entire second pill or liquid dispenser in the top shelf and several more pill dispensers on the bottom shelf, if that's how we want to proceed with our design. Excellent.
So this is our prototype for the remote notification system in which we used a special microcontroller called the MKR1000 to connect to the internet. The MKR was programmed using a service called Blink, which allows a user to communicate to and from a MKR1000 board with their Android device. What you're seeing here is a simple LED being able to be turned on and off by the press of a button from the Android device. But this does prove that there is an ability to connect to and from the system of the device from the Android application. However, we were not able to get a push notification working on the Android, and we are still researching as to what the problems may be there. However, we did meet the shall threshold for this RRP.
For specification 3, the liquid dispensing system, we based the total size of the unit based on our fridge measurements. We modeled our design in SolidWorks and decided to use 3D printing material instead of metalworking on the models, for we believe it would be more cost-effective and it would work just as well for our prototype units. The model shown on left was built on a stilt-based system, so we were able to test outside the fridge environment. The final design will have these removed and will be used with a screw-held system. The design was a 4-inch rotary and is able to contain 8 vials worth. Each hole is separated by a 45-degree angle and can be scaled down 1 more inch with 7 slots to fit more additional units within the fridge. The motor is to sit inside the system and can rotate a 0.24-inch shaft that is connected to the center of the rotary, and it will rotate. On the bottom, there's a motor on a rail system that will move back and forth and will push the vial in and out. Moving on to the data portion for this. On our analysis, we did 4 trials, 3 of which are shown here for 1 full rotation. Based on our visual analysis first, we saw that the rotary was not fully spinning on 1/8 ticks as was programmed compared to the pill dispenser. We had viewed the video within Tracker software to determine how far the degrees were off and collected this data shown on screen. Although close, it was off by a few degrees each time. This would not hurt in the short term, as the medicine would still dispense, even though a few degrees off. The long term, however, would build up with either a jam or dispense the improper medicine with the wrong hole in the slot. We have deemed this portion of the RRP a failure. On the bottom portion, where the rail is located, we deemed that a success, as it was able to move back and forth within 2 seconds without issue. And then the rotary can spin once more as it entered and exited slot 0. as we would designate at the bottom slot. We do believe that this is still possible, and we have our solutions to fix it. One of which is the shaft, the connector, and the rotary itself, all designed with a key slot. We can either use a welding system to the metal rod and use a tack and grind down to their appropriate size, or 3D print a rod at 100% infill with a key size already designed. We feel that we can still move forward with this portion despite the setback, and that this project can be a success. Moving on to the next slide for RRP4.
So in this slide, we'll be talking about a dry medicine dispensers. So the dry medicine dispenser was designed to be a spinning pill container. The inside space will be divided up into 8 equal compartments using a divider. 7 of those compartments will contain pills for 7 days of the week, and you can put in any pills that you want. And 1 compartment will be left empty and lined up with a drop slot at the beginning. The divider will be connected to a stepper motors. With every comment, the stepper motor will turn 45 degrees, just exact amount to line up 1 compartment against a drop slot and drop its contained down to the craft tray. Next slide.
Okay, for our alarm or alertion system, we have a couple slides to go through, but for our initial part, we started off with just looking at if we could sense whether the door was open or shut. But our actual spec says that the user should be notified via light or sound prompt on the device according to the program schedule. And we did meet the shall specification, but not the should, which is receiving a notification on Android device, as Ethan showed. So if we go to the next slide, you can see the program for the speaker, which was an alarm output system. We actually, before that even started on our first week of testing, did a basic blink program, which if you have done Arduino, you can just download from their sources in their library. So that just turns on like an LED for a certain amount of time and then off. So we can customize that as like a flashing light, which we actually did, which that's not shown here, but just a flashing LED. And that is one way of notifying, but we also wanted to have an audible way of doing that. So we have 2 circuits here. The one on the right is an amplifier circuit, which uses a non-inverting amplifier op amp set up with a gain of 10 volts. And this actually didn't function when we tested it. It was actually last week, but we were able to get a sound from the first speaker, the basic speaker circuit on the left, which just uses a 8 ohm speaker in series with a 100 ohm resistor. And that one actually did get a sound, but it was only loud enough to be heard within the surrounding, maybe 6 feet or the room. So going forward, our plan for that is to get an off-the-shelf part for that, but we'll talk about that later in our winter quarter plan. But the specification has been met as far as our shall. Going on to our analysis.
All right. So for the engineering analysis, a majority of our calculations have just been discussed when referencing each specification above. This includes the liquid and pill dispensers, how they were made, the dimensions, why we chose the dimensions, the Android application, what we've gotten so far, the analysis that we've done for that, as long as the motor controls. We also chose to forego some of the analysis that we deemed unnecessary for this project, such as the mounting hinges, the insulation, the defrost drains, and the processor speeds. At least for this quarter, we didn't find enough time and we didn't seem for that to be completely necessary to prioritize any analysis on that. When it came to identifying risks, we didn't see these to be extreme risks that would pose as difficulty solving in the following quarters. So we figured that we would be able to solve these in the following quarters without issue. for example, the mounting hinges, we may not actually be drilling into the fridge in any way besides the fridge door. So we would simply just be building housing units on SolidWorks and mounting those into the fridge in a way that may not necessarily need mounting hinges. So we didn't really look into that as a risk. Some analysis that we did discuss includes our dispenser's motor calculations in the Android application. And then things that we will continue to look into, we've looked into a little bit and we'll continue to look into those as priorities going forward, would be the things in blue. So temperature regulation, the grab tray, which includes insulation, sealing, leaking, the user interface, mounting for that as well. And then more of the user interface specifications. So moving on, this is some analysis that we did for our grab tray. So though we haven't implemented the grab tray into the fridge yet, it has been a concern that we've been kind of thinking about in our head throughout the whole quarter as to what the best option would be to do that. So that even though it didn't fit in any of our risk reduction specifications for this quarter, we do still find it to be a risk, and it's probably going to be our biggest priority going into the winter quarter. So we have done some research and some modeling for the grab tray, even though it didn't have anything to do with our risk this quarter. So as you can see on the left here, this is a SolidWorks model that we did. Obviously the dimensions may not be exactly what we want them to be when using our fridge, partially because we don't know the exact fridge that we're going to use. We don't know if we're going to use the one that we currently have right now or if we want to buy a new one. So we didn't specify those specifications on SolidWorks, but it's nice to have a design idea of what we want our grab tray to look like. So the purpose of the grab tray is to catch the dispensed medicine and create a safe and accessible way for users to take their medicine at any scheduled time. The grab tray will be integrated into the fridge door, must not allow any cool air to leak, and will remain well insulated and properly sealed. To implement the grab tray into the fridge door, we've thought about either replacing the door with a glass door that we could build the grab tray into, or we could move the ceiling on the fridge door that we currently have, expose the screws, add new insulation, add new ceiling, and basically modify the fridge door that we already have. We've also come up with a couple other ideas that we've been throwing around with each other, but we haven't decided on anything that's super dead set on what we're going to do. That is the purpose of the analysis, so that we can kind of get more towards that following winter quarter. So the grab tray, regardless, would sit at the bottom of the fridge door. It'd be spanning across the entire fridge door, so it'd be about 12 inches wide, and its depth would be reach about 5 inches deep, so that it can catch any of the medicine that falls. And then as for the next slide, we also did some analysis on the motor specifications. So the purpose of the motors is to turn the dispensers a specific amount to dispense the refrigerated or dry medicine by following the commands of the code that our CPE has written. And so for the dry medicine, there's one motor that drives the rotation device. For the liquid medicine, there are two motors, one to drive the rotation device and one to drive the rack and pinion that we've created in our design. The motor power is measured by determining what kind of motors will be needed, measuring how much power is needed to run those motors, the speed, efficiency, and the torque that the motor can withstand. And this would take away the risk by ensuring that the motors chosen will work under the conditions given by our project and the conditions that were created in our SolidWorks designs. So we did write a code to perform this analysis, and we chose to use the NEMA 2 phase stepper motor. So our code was written in regards to those specifications with the assumption that the motor runs steady state. The basic equations that we used in our code regarded resistance, phase velocity, mechanical power, the internal rate of return, mechanical loss, electrical power, and efficiency. And the results of the code of the motor are as follows in this little graph in the bottom right. And the code did show that the motor has enough power and efficiency to withstand our device. One thing to mention is that when you look at our specification for the liquid dispenser, we did have some problems with the motor providing enough power to turn it the exact amount, but we weren't exactly sure at the time of testing if that was the motor's fault or if that was the fault of slippage or any other reasons. So that's something that we're going to have to look into next quarter when we perfect our liquid dispenser design.
Continuing off of Clara mentioned earlier with the motor specification, everything we also went through earlier initially in the first part of the quarter of just some theoretical hand calculations of the torque required from these motors. These are based off just of these equations, and math that we did was just based off some rough estimates that we initially thought and worked with in the beginning of the quarter. Initially starting with around like 0.2 kilograms, around half a pound for each of the hand calculations. And yeah, initially just used used calculations to measure the estimated angular velocity and the energy equations to find the torque required. As Claire mentioned, comparing to our specifications in the motors, this is just to make sure that our motors will be able to run and turn our dispensers effectively and accurately with the specific torque required, as seen at the bottom there below. We believe just from looking at the specific specifications that we had earlier that this would be not an issue for us, but rather through testing and through a lot of our design process that we learned that a lot of the big factors when it comes into both of these dispensers is a lot in the size and weight of these dispensers. So affects a lot of other factors in terms of such as like the bending on our rod as it turns the liquid dispenser, and also just the weight if it the weight as the dispenser could be bigger or smaller, as we had also an RRP about the size and fitting in all into our fridge storage that we are still, as mentioned earlier, unsure about in the which fridge storage we will use, but also making sure that we have enough space to fit all the dispensers and meet all of our specifications that we mentioned. Moving on to the full block diagram, this is just a bigger picture of what we have in mind for our project overall. This is broken down into an electrical and a mechanical side, and all sourced from a power distribution panel, as Wes mentioned initially in the critical paths. Going into the mechanical side of it, we have seen on the right side, it's broken down into both the storage, liquid medicine, and dry medicine. So the storage would be part of the RRP, where we need to make sure that the liquid and dry medicine all fits effectively inside our fridge storage that we have. This also includes the grub tray and making sure that it is sealed and insulated properly to regulate ambient temperature. And then moving on to, we also have our liquid and dry medicine. So going into the liquid medicine, we have updated from our pre-RRP version of understanding we have two different motors, one for the to push out and dispense medicine, but also one to rotate the turntable so the next medicine can be dispensed at the proper time. And then also into the dry medicine, where we have the one motor to at the bottom that will turn the turntable, and through what we mentioned earlier from our testing, that it has effectively been working for us and passed our RRP. And then Drew later on will also go into our electrical part of the block diagram.
Yeah, so thanks, Justin, for showing that. All of these motors on the right, so the two dry medicines, we only have one built right now, but those are all connected. So the green arrows show the microcontroller signals that will control all of the motors, and it also controls the power going to each one. So our new things that we've changed since the pre-RRP version and just planning to go forward is the alarm, which it consists of lights and sound, but we're just specifying that to be more succinct. And then our door open sensor is in the same place, but that's something that we've worked on. Our keypad and buttons is something that we're going to be starting on winter quarter, and that is for the fridge door and like the locks mechanism sensor. So that controls like access to it. And then the other crucial part of our final full block diagram is the application with the connection to the microcontroller, which is what Ethan's been working on. And we have it connected as of now, but we also want to have a built-in screen on the device to give the user just input about like what's going on the device, like if they need to know anything. And that's for like, if they don't have like an application. The only other change with that we've shown is just a difference in color coding. So hopefully that makes the diagram more clear and easy to read. And yeah, we're going to go into our winter schedule. So for our plan for this winter break, the main parts that we're going to be focusing on are ordering materials, as we're going to have high lead time. So we want to avoid that for winter quarter, kind of like the problems that other teams have been having with fall quarter and ordering parts. We're also going to we're working with the liquid medicine dispensers and just like perfecting those adjustments, as Wes and Claire talked about. They talked about the specifications for that and how the angles were off. So that's going to be worked on a little bit. And then we're also going to be looking more into the grab tray. And for me and Ethan, user interface design, and also like starting on ordering, as far as ordering parts goes, we're going to be looking into some sort of padlock device and just the alarm system, because if we need to order parts, we need to get those ahead of time. And yeah, our also descriptions on the left, I've kind of gone over all of them. So just the locking device, and then we also need to be able to connect the Arduino. So that's something that we'll be troubleshooting over winter break. And then for the first week, you can go to the next slide.
So this is our schedule for the first week of next quarter. So what we're gonna need to do is we're gonna need to get material so that we can make the custom fridge door that can fit a craft tray. Next, we're gonna have to prepare the fridge for that by taking off the fridge door without damaging any wires or core inside it. Next, the microcontroller will be updated. And then the code from fall quarter will be modified and add more to it so that we can use it with the user interface. And then finally, the interiors of the fridge will be modified so that we can run a whole electric circuit through it to power the motors. And next slide.
Okay, and finally, these are our references that we used. And next slide, Drew. Thank you. Any questions? We'll get into questions with the actual presentation.
Thanks,
Okay, well,
everyone.
thanks,
and
Just throw that
everybody.
into the video we submit.